Okay, let's see the last class. We are discussed up to 17 questions. Now let's see 18th question. It's very easy question only. Just one reaction they gave. What is that reaction? X plus X is converted into 2y plus Z. 2y plus Z they gave. Then the initial pressure is equals to initial pressure of X, Px is equals to 90 mm of Hg they give. Now at time t, if time t and final pressure of X is equals to, it may decreases some value, that is, let it may be the initial pressure Px is equals to A is equals to 90, then it decreases some amount, it is a small x, then how much amount of pressure will form due to that y, it is 2x, and due to that x, z is formed pressure is x, then that if time t at time t is equals to 10 minutes, the total pressure is equals to 180. This 180 is equals to a minus x plus 2x plus x. This and x will cancel. Then 180 is equals to the initial pressure is equals to 90. 90 plus 2x, then 2x is equals to 180 minus 90 is equals to 90, then x is equals to 45. So at time t, if t is equals to 10 minutes, at t is equals to 10 minutes, the final pressure of x is equals to a minus small x, means 90 minus 45 is equals to 45. This is the final pressure. Okay. Now for this equation, what we have to find out, rate constant we need to find out. It is the first order reaction, means first order reaction rate constant is equals to K is equals to 2.303 by T into log initial pressure by final pressure at time t of reactants, then the K is equals to 2.303 by, here the units are present in second inverse, but time is in 10 minutes, means 10 into 60 seconds, because 10 minutes is nothing but 10 into 60 seconds is around 600 seconds into log initial pressure of A is equals to 90 and final pressure of X is equals to 45. Then is nothing but how many times? 2 times will cancel. Log 2 value is 0.3. Then 2.303 by 10 into 60 into 0.3. This is on simplification. We'll get approximately 1.15 into 10 to the power of minus 3. 1.15 into 10 to the power of minus 3 second inverse. See, the answer is third option. The answer is a third option. See, for this question, what we have to find out, initial pressure of reactant they gave, but the final pressure of reactant we don't know. But the time t is equals to 10 minutes, the total pressure of the reaction we know that is equal to 180 mm of Hg. That 180 mm of Hg is formed by the reactant pressure, some x mm of Hg pressure is decreased from the reactants, and 2x amount of pressure is formed due to that product of 2y moles, and x amount of product formed due to that 1 mole of Z. Then the total pressure is equals to A minus X plus 2X plus X is equal to 180. Then X is equal to 45. Then how much amount of pressure is decreased? 45 mm of Hg pressure is decreased for the reactants. Now the final pressure of A is equal, reactant is equal to 90 minus 45 is equal to 45. Okay. Then the answer is 1.15 into 10 to the power of minus 3. Let's see 19th question. This reaction is carried out in first order kinetics. Sorry, zero order reaction. The 19th question, if it is zero order reaction, then the T half-life period is directly proportional to initial concentration. Let's see, they gave in a reactant, it contains 4 moles are present. If the 4 moles converted into 2 moles, the 4 moles are converted into 2 moles, means it required time T half is equals to how many minutes they gave? 2 minutes time they gave. 2 minutes. In the same way, in a reactant having instead of 4 moles, 8 moles are present. Okay, 8 moles. 8 moles are present. These 8 moles are converted into 2 moles, required how much time? First, that 8 moles are converted into 4 moles. This is half. This required time. For example, 4 is converted into 2 minutes, means this 8 moles are converted into 4 moles, means it requires T half is equals to 4 minutes. Again, these 4 moles are converted into 2 moles. It required T half is equals to 2 minutes. Then the total time required for this T conversion of 8 moles into 2 moles. This is 4 moles. 8 moles into 2 moles. The required time is 4 plus 2 is equal to 6 minutes. Okay, so the answer is 6 minutes. The answer is 6 minutes, ma. In the same way, if the reaction is carried out in first order reaction, if n is equals to 1, means first order reaction, then let's see how much time is required. The first order reaction is independent of the initial concentration. 4 moles converted into 2 moles. Then T half is equals to 2 minutes. Okay. And half-life period T half is independent of concentration. Okay. In the same way, the 8 moles are present. 8 moles. 8 moles are converted into first 4 moles. See, either 8 moles are present or 100 moles are present. Its half-life period of first order reaction is independent of the initial concentration. In the above case, how much it is half-life is takes 2 minutes. In this case also, half-life is equals to 2 minutes. Again, this 4 is converted into 2. This half-life T half is also is equal to 2 minutes. Then the total time required for this conversion is equals to 2 plus 2 is equals to 4 minutes only. Because for first order reactions, half-life period is independent of the initial concentration. That's why K is equals to 0.693 by T half. Means T half is equals to independent of the initial concentration. But zero order reaction, T half is directly proportional to the initial concentration. That's why initial concentration is increases, its half-life value will be increases. If the initial concentration is decreases, half-life will be decreases. See, 4 is converted into 2 minutes. then 8 is converted into 4 means it is double 8 converted into 4 means then 2 plus 2, 4 minutes time is taking. Again 4 is converted into 2 means it takes 2 minutes only, because T half is directly proportional to initial concentration. Initial concentration is more, then it requires more time for its half-life, for every half-life. Okay, this kind of questions are very very important for NEET and JEE examination. See, I did that another question also. The same question I showed that zero order reaction and first order reaction, but in this question they're asked for zero order reaction how much time takes. This time is 6 minutes. This total 8 is converted into 2, it takes 6 minutes. But if the same reaction is proceeding, first order reaction, how much time it takes? Only 4 minutes. Okay. Okay, let's go for next question. 20th question. Let's see. A is converted into B. The K1 value they gave. C is converted into D. K2 value gave. T1 and T2 are the half-life periods of two reactions. Then what is the relation between their half-life values between T1 and T2? Means it is first order kinetics. Like based on the units, K units are second inverse, means it is first order reaction. The first order reaction K is equals to 0.693 by T half. Okay, T half is inversely proportional to K, or K is inversely proportional to T half. Then okay, let's see T1 by T2. First T half by second T half is equals to K2 by K1. K2 value and K1 values they gave. K2 is equals to 0.693 minute inverse. That 0.693 minute inverse is nothing but 0.693 into 60 second inverse. 60 second inverse by 0.693 second inverse. Then the 0.693 will cancel. T1 by T2 is equals to 60. Then T1 is equals to 60 into T2. T1 is equals to 60 into T2. So the answer is second option. So the answer is a second option. Okay, let's see the 21 question. 21, what they gave. The given reaction is following zero order kinetics. Okay, the T half, if pressure is equals to 4 atmospheres and 25 seconds, and another T half at that pressure is equals to 16 atmospheres, then the T half value we have to find out. Okay, see for this zero order kinetics, for zero order kinetics, zero order reaction, T half-life period is directly proportional to initial concentration or pressure. Okay, according to that, first T half by second T half. First T half by second T half. Okay, second T half is equal to P1 by P2. Now, the first T half is equals to 25 seconds by T2 is equals to P1 is equals to 4 by 16. It will cancel 4 times. Then T2 is equals to, sorry, T2 second half-life period is equals to 25 into 4 is equal to 100 seconds. 100 seconds. So the answer is third option. Because see, just 20 and 21 both are the same concepts. But the 20th, the reactions are proceeding in first order kinetics. That's why first order kinetics half-life period is independent of the concentration. Then rate constants and half-life relation. Half-life is inversely proportional to rate constant of first order reaction. Now let's see that 21. The 21 question, half-life periods and time value they gave. At that time, concentrations they mentioned in terms of pressure. Then that half-life is directly proportional to pressure or concentration. According to that second half-life value, we are calculated. Okay, it's very easy. Next, let's go for 22nd question. 22nd, DDT on exposure to water decomposes according to first order kinetics. Its half-life period is 10 years. Then how much time it will take for decomposition of 99%? For first order reaction, K is equals to 0.693 by T half. Then half-life period, already they gave how much? 10 years. Is nothing but 0.693 by 10. 0.693 by 10 is equals to 0.0693. Year inverse. This is K value in years. And this, by using this K value, how much time takes for decomposition of T99%? Means DDT, dichloro, diphenyl, trichloroethane is 99% is decomposed, means 99% is converted into products. Just 1% is left, 1% reactant is left. So for that decomposition of 99%, how much time it takes? Then for this case, first order kinetics K is equals to 2.303 by T into log A by A minus X. Okay, now the K value we know that is 0.0693 is equals to 2.303 by T into log 100 by 100 minus 99. 100 minus 99 means 1 log 100 value is 2 and log 100 is nothing but log 10 square is equals to 2 log 2. 2 log 10 is equals to 2. So this value is 2. Then the T is equals to 2.303 by 0.0693 into 2. On simplification, we will get approximately 66.46 years. Is nothing but 66.5 years. See what is the answer? Answer is second option. See, directly we can't calculate because the rate constant we don't know. That rate constant we are calculated for first order reaction by using its half-life value. After that, we are find out that how much time required for the decomposition of DDT by 99%. Okay, how much time is required? Complete decomposition of 99% of DDT. It takes 66.5 years. 66.5 years. Okay, let's see for 23rd question. 23rd question is very easy. just already this kind of concepts we are discussed earlier only. The rate of first order reaction is 0.0. First order reaction rate gave 0.04 mole liter inverse second inverse at 10 minutes time and 0.03 moles at 20 minutes time. Find the half-life of the reaction. See, for this case, first we have to find out its rate constant. We have to find out its rate constant. Okay. Now, for this first order kinetics, rate is equals to K into concentration of reactants. Let it be A power 1. Now, its rate value, how much they gave? The rate is equals to R1 is equals to 0.04. 0.04 R1. If time is equals to T is equals to 10 minutes, if T is equals to 10 minutes, then R1 is equals to 0.04 is equals to K into concentration of A at 10 minutes. You have to consider this is equation 1 and T is equals to 20 minutes. Okay, then the rate R2 is equals to 0.03 is equals to K into concentration of A at 20 minutes. From this equation 1 and 2, 1 divided by 2 then is nothing but 4 by 3 is equals to concentration of A at 10 minutes by concentration of A at 20 minutes. Let maybe this is initial concentration and it is final concentration. That value is ratio is 4 by 3 and the time period, this time is equals to, this is T1, this is T2, T2 minus T1 is equals to 20 minus 10 is equals to 10 minutes time period. Okay, during this time interval, the 10 periods time interval, we have to calculate its rate constant. First K value we have to find out. After that, we have to find out half-life period. For this, K is equals to 2.303 by T into log concentration of A at 10 minutes by concentration of A at 20 minutes. Okay, then the K is equals to 2.303 by 10 into log, this is 10 minutes, they gave the 10 minutes, we have to convert it into seconds. Okay, actually options also they gave in minutes only, no need to convert into seconds. Log A10 by A20 is equals to 4 by 3. We know that log 4 value is 0.6 and log 3 value is 0.477. Okay, log 4 by 3 is nothing but log 4 minus log 3. Then K is equals to 2.303 by 10 into 0.6 minus 0.477. 0.477. That's why, dear students, we have to remember logarithm values log 2, log 3, log 4 is nothing but 2 log 2, log 5, log 6, log 7, up to log 10 values we have to remember in our mind. Because sometimes in objective exam they will give the value, sometimes they won't give. However, we have to remember, then only we can solve very easily. Okay, then on simplification, this K value how much we'll get? 0.0288 minute inverse. Now what we have to find out? Half-life value we have to find out. For first order reaction, T half is equals to 0.693 by K. K is nothing but 0.0288. This is on simplification, we'll get 24.06 minute inverse. Sorry, half-life means 24.06 minutes. See, the answer is second option is correct. See here, for calculating its half-life period, they are not given directly K value for first order reaction. So that K value we have to find out that time interval 10 to 20 minutes. The time interval is 10 minutes. During that time interval, K value we are find out. Because at the initial time is 10 minutes, then that state the initial concentration of reactant and the final concentration of reactant at time is equal to 20 minutes. That ratio is equal to 4 by 3 km. The time interval is 10 minutes. According to that K value we are find it out. By using that K value, we are find out half-life period. Okay, students. Let's go for 24th question. One reaction they gave A is A plus B is converted into products. Concentration of A is 0.1, concentration of B is 0.2, the rate is equals to 0.05. This let it be equation 1. Then concentration of A is increased 2 times. 2 times it is increased. Okay. Concentration of A is increased. Concentration of A is increased 2 times and rate is also increased. Rate is also at this state rate is also increased 2 times. Okay, let it be this equation 2. Now let's see that equation 3. Equation 3, the concentration of reactant A, concentration of B is decreased 2 times, but rate is same. Rate is same. Rate is same means the rate is independent of concentration of concentration of B. Hence, order with respect to B is equals to 0. Now the rate expression is equals to K into concentration of A power X. Now that X value we have to find out. After that we have to find out its half-life period. Now let it be equation 1 and 2. R1 2 by 1 you have to do the equation 2 by 1. The equation 2 by 1 is nothing but R1 by R2. Sorry, R2 by R1 is equals to 0.1 by 0.05 is equals to concentration of A. Concentration of A is 0.2 whole power X by concentration of B. That is another concentration is 0.1 whole to the power of X. Is nothing but 2 by 1 is nothing but 2 is equals to 2 power X. Then X is equal to 1. X is equal to 1 means it is first order reaction. It is first order reaction. Okay, for first order reaction, half-life period is equal to 0.693 by first order reaction half-life period is equals to 0.693 by K. But K value we don't know. From the equation 1, you have to take any one equation. From equation 1 equation, the rate 0.05 is equals to K into concentration of A. Concentration of A they gave 0.1. Now from this K is equals to k is equals to 0.05 by 0.1 is nothing but 0.5 came 0.5 second inverse. Okay, now k value we know that, then half-life T of is equals to 0.693 by k, then 0.693 by 0.5. On simplification we are getting 31.386 seconds. 1.386. Half-life period is, calculate the half-life period means not second inverse ma, units are wrong, seconds only. So the answer is first option is correct. First option is correct. Let's see for 25th question. See, the 23 question actually at different concentrations of A and different concentrations of B at that time rate they gave. Okay, but order of the reaction they are not mentioned. By using the data we are find out that order of the reaction is depends on order of the reaction is 1, and that order also with respect to A only. It is independent on B. That's why the order of the reaction is 1 with respect to A, and it is also equal to total order of the reaction. Okay, so that's why the rate is equals to K into A concentration of A. So the first equation rate is equal to 0.05 is equal to K into concentration of A. From that K value I find out. So if you know the K value, then we can calculate half-life period of first order reaction very easily. Okay, let's see for 25th. 25th question is very big question ma. This ether CH3O CH3 dimethyl ether is converted into methane plus H2 plus CO. Okay, for this at a time t is equals to 0, at a time t is equals to 0, the pressure, initial pressure of dimethyl ether is 0.04 atmospheres. Okay, 0.4 atmospheres. Now if time, if t is equals to 12 minutes, then the pressure of dimethyl ether is decreased some amount, that it may be x 0.4 minus x. Okay, and how much pressure is formed due to that methane is x, and hydrogen gas is x, and carbon monoxide gas is x. Now the total pressure, if t is equals to 12 minutes, total pressure is equals to, total pressure is equals to 0.4 minus x plus x plus x plus x. Then one x will cancel, is nothing but 0.4 plus 2x. 0.4 plus 2x. This is that final pressure. This is initial pressure of the initial, this is the total pressure is 0.4 plus 2x. This is the final pressure is 0.4 minus x. But for this equation, K is equals to 0.693 by T half. T half value is they give 14.5 minutes. 14.5 minutes. Then on simplification we'll get 0.0478 minute inverse. Now we have to find out x. Find out x value. Okay. Then after that we have to find out total pressure. Then we have to find out x value and total pressure. For this case, K is equals to 2.303 by T log A by A minus X. Log A by A minus X. The K value is 0.0478 is equals to 2.303 by T is 12 minutes into log the initial pressure is 0.4 and final pressure of dimethyl ether is 0.4 minus X. Okay, from this we have to simplify this equation. We have to simplify this equation. Log 0.4 by 0.4 minus X is equals to this value means 0.0478 into 12 by 2.303. On simplification we'll get